So we've come to an incredibly sweet spot in our class. Namely, the spot in our class where we actually have enough tools to say something about what Euler said long time ago. About 300 years ago, e to the ix. Prior to Euler, there was no Euler's identity. But Euler changed all that, and it starts with something like this, as basic as the polynomial expansion of e to the x. We did this earlier in some of the previous examples, and we established that this could be true for all values of x, almost all. You could basically substitute anything you want into these spots, right? So Euler did something unthinkable. Instead of putting a real number in there, he stuck in there a complex number, non-real complex number, ix. He put ix here, which would be go with ix here, ix there, ix there, ix everywhere. You see in there, I times x, and then what happens? He gets that e to the ix is equal to 1 plus ix plus, this is ix squared. That would give you negative, what? That would give you negative x squared, of course, because I times I is negative 1. Plus, this is I times I times I. That's negative I, x to the third over 3 factorial. Plus, this would be I times I times I times I. 4 i's. 4 i's. That's what they used to call me in high school. That would give you just 1. That's x to the 4 over 4 factorial. Plus, this is just I, x to the 5 over 5 factorial. Plus negative x to the 6 over 6 factorial, plus negative I, x to the 7th over 7 factorial, and on and on and on and on. You say, whoa, now you've made a miss, old Euler. But wait, what if you spot these things and you're looking at it and you spot a few things that you notice, this has an I, but this has no I. This has an I, but this has no I. This has an I, but this has no I, and this has an I. What if you went ahead and did something brave and separated them into the ones that have I's and the ones that don't have I's, the real part and the imaginary part? So this one, the 1 would go here, the x would go here. The x squared has no I, so it would go here, minus x squared over 2 factorial. That one has an I, so it would go over here. So it would go to minus x to the 3 over 3 factorial. That one does not have an I, so it goes over here, x to the 4 over 4 factorial. That one has an I, so it goes over here. So it's plus x to the 5 over 5 factorial. That one has no I, so it goes over here, 6 over 6 factorial, and on and on and on and on. So okay, nice, but wait, here's the punchline. Amazing, amazing. The left hand side tells you that this is e I to the x, and this should look familiar because we just did it a few minutes ago. This is the famous expansion for cosine of x. Stop me if I'm lying. It's hard to control my voice now. What happens here? This is the famous expansion for sine. So this becomes I sine of x. And this, my friends, is the most beautiful equation in our world ever created by humans. Chew on that. Alright, I'll see you guys here next time. Peace.